Okay, so hi students. Today what we are going to do is we are going to go through a few of the concepts that we tend to overlook at times when we are solving questions. And these relate to solving of equations, and we'll be taking up these concepts that you should be aware of, because if you are in class 9th and 10, maybe they would not impress you so much, but probably when you go to class 11, these would form a very strong foundation of what you're going to learn in the classes ahead. So the first thing is extraneous roots. So let's see this with the help of this example. You have an equation to solve. So you have x root 3 is equal to root x 1 minus x squared, and you have to solve this equation. The first thing that you would do is we square square both sides. This is the obvious thing that we do. So squaring the left hand side, we get 3x squared, and on the right hand side we get 3x squared minus 1 minus is equal to 1 minus x squared. Now we solve this, so we get 4x squared is equal to 1. So you have x is equal to plus minus half. This is what you get, x as plus minus half. So you'll be tempted to say that the answer for this particular equation is x is equal to half and x is equal to minus half. But let's see if these two values satisfy the given equation. So you have x is equal to half. So you have on your left hand side, you have root 3 by 2. And on the right hand side, you will have root over 1 minus 1 by 4, which is root over 3 by 4, which is root 3 by 2. So 1 by 2 is definitely a root of this given equation. But let's see what happens when we take x is equal to minus 2. When we take x is equal to minus 2, the left hand side becomes minus root 3 by 2. However, on the right hand side, you have root over 1 minus half square is again 1 by 4. So you get 3 by 4 under root, and the value would be root 3 by 2. So the left hand side is a negative number, whereas the right hand side is a positive number. In that case, x is equal to minus half is not a solution of this particular equation. Now the question to be asked is, how did we get this value when it does not satisfy the given equation? Traditionally, what we do is we solve an equation, and whatever the values that we get, we write them as the answers. But in this particular case, we see that this is not the case always. Now, the reason for that is when we are squaring both sides, we are actually adding values. We are adding extra roots. It is true that when 1 is equal to 1, 1 square will be equal to 1 square. This was the basic assumption based on which you squared and you found out the solutions, and you wrote x is equal to half and minus half as the answer. But equally true is the fact that minus half square is also equal to 1 square. But minus 1 is not equal to 1. So this extra root comes in because of this thing that has come into picture. We assumed this situation in vice versa. So we said that 1 is equal to 1, so 1 square is equal to 1 square. And we assumed by implicitly here that when 1 square is equal to 1 square, then 1 is equal to 1. We neglected this particular case, and this actually gave us that extra root. So in such circumstances where you are squaring the equation and you are increasing the degree of x, you might get extra roots. So whenever you do such a kind of activity where you square both the sides of the equation, when you get the values of the roots, you must substitute them in the original given equation and see if they satisfy the equation or not. And only then will you, only then should you write whether these particular solutions qualify as a root for the particular equation. Okay, so this is regarding extraneous roots. The second condition is the loss of roots. Now you have an equation where you have x into 3x plus 1 is equal to x into 2x plus 4. A general student, what he would do is he would cancel out the x's and he'll get x is equal to 3 as the answer, right? When you substitute, you will get that x is equal to 3 is indeed a solution for this particular equation, and you will be tempted to believe that this is the only value. Again, here the degree of x is 2, but you got just one equation. So that should set the alarm bells ringing. But even if it does not, one thing that we ignored here by cancelling out is that there is a value of x equal to 0 that satisfies this given equation. If we cancel the x's out, we lost that particular root. So the correct way is not by cancelling both the sides of the equation, but by taking all the terms on the one side. So what we get here would be x would be common. You get 3x plus 1. And when you take this particular thing on the left hand side, you get minus 2x equal to 0, which implies x minus 3 is equal to 0. So in this particular case, x could be 0 or x equal to 3. There are two solutions, x equal to 0 and x equal to 3. If you cancel out the factors containing the variable, then there is a chance that you lose roots, actual roots of the equations. The previous concept was regarding getting extra roots in your solution, and this particular example covers a situation wherein you lose roots. So whenever you are solving a particular equation, be careful that you don't simply cancel out the variable factors on both sides of the equation. Check and take common and then try to find out what the solutions of the given equation would be. Otherwise, you'll be losing roots. So this is about loss of roots. The third thing is denominator cannot be 0. So let's take this particular question. You have 10 divided by x into x minus 2 plus 4 by x equal to 5 by x minus 2. Okay. So on the left hand side, you get this. We have 10 plus 4x minus 2 is equal to 5 by x minus 2. So now you have 4x plus 2. I don't cancel out the x minus 2, so I cross multiply, so you get this, and you have 5x x minus 2. Okay. I'm not cancelling out because again we saw in the previous example that there could be a loss of root, so I did not cancel out. And I cross multiply. So you take everything on the one side. You have x minus 2 as a common factor, and you have 4x plus 2 minus 5x equal to 0. So you have x minus 2 and 2 minus x is equal to 0, which means minus x minus 2 whole square is equal to 0. Therefore, x is equal to 2. Two values you will be getting, but they are repeated roots. So the value that you get is x is equal to 2. So we did not violate any of the conditions that we studied in the previous 2-3 examples. But again, this x is equal to 2 is not a solution of the given equation, because when x equal to 2, the denominator of two of the terms becomes 0, which is not possible. In maths, you cannot have the denominator exactly equal to 0. Hence, x is equal to 2, although you got this solution, does not qualify as the actual root of the given equation, because in that case the denominator would become 0, which is not possible. So here x is equal to 2, although you got this value, this does not qualify as a solution for the given equation, as in this case the denominator becomes equal to 0. So these are a few examples wherein we saw that we tend to make very simple mistakes, conceptual mistakes, which actually lead us to getting extra roots, losing roots, or getting values which do not qualify mathematically as a solution. So be careful when you are solving these equations. Probably when you are in class 9th and 10th, you would not get any question related to these things, but it's always good to be conceptually sound, so that when you proceed in a higher class or you study maths at a higher level, you do not get bogged down or you do not get caught up in a conceptually wrong space. Okay, so these are some of the concepts related to solving equations.